Welcome to calculating a test statistic for a mean. In this problem, it says homeowners claim that the mean speed of automobiles traveling on their street is greater than the speed limit of 35 miles per hour. A random sample of 101 automobiles has a mean speed of 36 miles per hour and a standard deviation of 4 miles per hour. I'm going to highlight the claim here. It says the homeowners claim that the mean speed is greater than the speed limit, which is 35 miles per hour. This is maybe why they might put like speed bumps in the neighborhood or something like that. Some homeowners complain, and then you see those speeding little contraptions that the police put out here. So we're testing the claim about a mean, so we're going to use mu for HO and HA, and it says that it's greater than, and since it doesn't contain equality, it's going to be with the alternative hypothesis. So it should be mu is greater than 35 for H sub A. And remember, this is where the claim is going to be. This means H sub O should be mu is less than or equal to 35. And we're going to use that underlying assumption that the claimed mean, remember that the claimed population mean is going to equal 35. To calculate our test statistic, we're going to use the formula from above. For the test statistic for a mean, we're going to use a t-test statistic, and it's going to be the sample mean x bar minus the population or claimed mean mu all over s divided by square root of n. I'm going to go ahead and put parentheses around the numerator and parentheses around the denominator here. Next, we have to substitute all our formulas. In this problem, we know what the claimed mean is 35, but we need all the sample statistics. It says a random sample of 101 automobiles. That means n is 101. The sample for those 101 automobiles is 36. And then the standard deviation for that sample is going to be 4. Let's substitute those values into our formula. X bar is going to be 36 minus our claim mean, which is 35. They're very close. I'm going to put that numerator in parentheses, divided by s, which is 4, divided by square root of n, which is 101. I'm going to put parentheses around the 4 divided by square root of 101. On our calculator, we type in the parentheses as we see them. So it's going to be, let me move this up a little bit so you can see that a little bit better. Okay, so open parentheses, 36 minus 35, close parentheses, divided by, open parentheses, 4, divided by square root of 101. And close parentheses. That gives us our answer of 2.512468905. Let's just try this example on StatCrunch. Since this is testing a claim about a mean, we're going to go under Stat, and then we're going to go under T-Stats, because remember, means are with T's. We're going to go one sample, then with summary. Our sample mean in this case is 36. Our sample standard deviation is 4. Our sample size is the 101 vehicles. It's a hypothesis test for the population mean mu, where h sub 0 equals our claimed mean is 35. That's why we have equal to on StatCrunch, because it does the claimed mean. And then h sub a, our inequality, is going to be then greater than. I'm going to move down here a little bit and do p-value plot and hit compute. Let's double check our answers. Our test statistic, 2.5124689, and we're good.